Permission denied. Okay. All right. Still doesn't change over. So we're now moving to the second part of the training, which is data management. And so these two parts are closely related. I'm Stephen Tim. I'm the co-lead of data management for DUNE. And this software is in a state of flux. We've been, over the past 4 years, making up new data management software for DUNE. So you're going to see a preview of what that's going to look like, but it's not in production yet for the most part. So currently we use SAM to find and manage our data. It stands for Sequential Accessible Metadata. It was developed at Fermilab originally by D0. It has been morphed over the years. And this will show you how to find files in the DUNE data catalog. So this part should all work. Read access from SAM, even from CERN, even this part should work. I can't swear to that, but it should. So the SAM package is called SAM Web Client. You have to export that your SAM experiment is DUNE, because there are many different SAM installations for each one of the existing Fermilab experiments. So that's SAM. I'm going to say a couple words about Rusio. You've heard some about this already. Rusio is the next generation data replica server. It was originally developed by Alice, is now in use also by DUNE, by CMS, by Rubin Observatory, and a lot of smaller experiments, Bell2 also. So it's gaining very wide acceptance here. And it's a replica catalog. Rusio knows where the files are and also how to get them there if they're not there. So it's a rule-based system. I want this file there. If it's there, it will stay there. If it's not there, it will get it there. And then we'll return the nearest replica of any data file for use in either interactive or batch use. We are expecting that most DUNE users will not regularly be using direct Rusio commands, but other wrapper scripts that call them indirectly, especially inside of jobs. We intend to wrap this. So you'll have very little to do. The only case that you would need to is if you're an analyzer or if you're a detector commissioner at ProtoDune, say. These are going to come in handy fairly soon. The Rusio client's installed in the CVMFS. You can set up Rusio to get it. Most DUNE users, including the only people in this room that can do it right now are myself and Heidi and Andrew, I think. So the rest of them don't try this. This will not work for you. But list file replicas will list replicas. Rusio download would actually pull a file to you. Rusio talks about DIDs, which is a data identifier. Data identifiers can either be a file or a data set, which is many files, or a container which contains many data sets. And typically we're setting up our data sets so that each run is a data set for us. A replica is a copy of a file in a specific location. So Mike showed you a place layer that the files in Fermilab and Rutherford, so that has two replicas. Most of our files do have more than one replica. A scope is a collection of related data. Most of our Rusio scopes are mapped to detector type, ProtoDune SP, ProtoDune DP, vertical drift cold box top, horizontal drift cold box, horizontal ProtoDune. A rule is an instruction to move a file or to get it there and keep it there. And when we talk about RSE, that's a Rusio storage element. And we have approximately 15 of them around the world right now. Okay. I'll also mention Metacat briefly. We will not actually do anything with Metacat. But if you were at the near detector session this morning, you saw a preview of what it's going to be like. We have a Metacat client in DUNE CVMFS. There's very good documentation in Metacat reads at x.io. My apologies, these links are not live. You have to cut them out and paste them to a browser. Metacat Web UI is available at the GUI. And you should actually be able to log into that. You can't do anything yet, but you should be able to log in and see what's there. So now going back to SAM. So if you have a given file, you can say SAM web locate file. And this shows that it has 4 locations for this particular file. I can't swear they're all still there from the time I made this slide, but this is what it was when the time I made this slide. So SAM has logical names. This shows that it's known to Rusio already, the Rusio colon thing. certain EOS, Castor, which really isn't Castor anymore, and NSTOR, which is at Fermilab. So Sam has the notion of what are called data disk, and each one of them has got a key name by which Sam knows it. And then Sam and IFDH take care of the thing of figuring out what is the host name of that at any given time. So to list all the files, so Sam has got a query language, dates from the days of Alta Vista. Sam will have list files, so you can make a query, and there are many dimensions in which you can query, and you can end ors and nots, and all the rest of the things. But say I want to list all the files in run number 5758, run type proto-dune SP, data tier raw, and that will give me a lot of files. That was a big run, but it looks something like that. It will list all the file names. Suppose I want a reconstructed version, I would do the same. Well, so just going over these things, you have run type, which we call it run type, but it really is the detector type. So major detectors, proto-dune, SP, proto-dune, DP, cold boxes, fire detectors, all have got the run type. Data tier, you have raw, you have full reconstructed. There's also detector simulated. There's also hit simulated, hit reconstructed. And then you can select a version. Do we still have that on disk? We shouldn't. These files have been reconstructed at least 3 or 4 times by now, and hopefully no proto-dune analyzer actually using this particular version anymore, but anyway, it's there.
That's version 2?
No, this version was 0.
Ooh.
Or well, version VO7 of Dune TPC, which was about 4 years ago. We've twice reprocessed it since then.
Oh yeah, please don't use those.
Don't get any physics out of this file. It's still there, but you know. But the point is that Sam also tracks parentage. This is the other thing. This is why we needed to make a different. Rusio has got some metadata inside it. We couldn't, but it doesn't know the concept of parentage, and parentage is very important to know. I'm sorry, was there a raised hand? No. So I have a reconstructed file. I have to know what was the parent of that file. What raw data did that come from? And by which generation of the offline, by which version of the offline did I make that reconstruction, and so forth. So we're tracking the application version, we're tracking all that type of thing. And so this useful proto-dune Sam web parameters. Now, in proto-dune, we threw a whole bunch of crap into the metadata. And that annoyed me so much that
we were moving it into the runs database.
yeah, so we got a real run. Oh, come on. I didn't realize this would take me to the wiki. To get into the wiki, you have to be a DUNE member or a CERN member, and then you have to beg Maxine to let you into the wiki. And then sometimes you file a service that's ticketed you after Maxine lets you into the wiki. No, I'm not going to follow that. Sorry. Our apologies for Fermilab using the worst wiki in the world, but we can't help that. Anyway, that article shows all the various parameters of proto-dune. DUNE-data.fnl.gov lists some official data set definition, but it's not up to date right now. It will be in the next week or two. So accessing data for use in your analysis. Expert D is a tool to use. Mike already covered that some, but it will only work if the file is staged to the disk. So if I tried to just open a file with WAR that was not staged, it would fail, or possibly just hang forever until it's staged. But I think not. I think it would just actually fail. And you can stream files if you're a member of the DUNE VO. So where is the file? So I showed SamWeb locate file, but there's a more specific one which is called SamWeb give file access URL. And when I do SamWeb give file access URL, it gives me the very whole thing that I need to get this with root. So you see it's got root : host port, full path name and file name. And the schema equals root. You could also say schema equals HTTP. And there has historically been GSI FTP as well. That's going away. It's not quite gone yet, but it's going.
Unfortunately, it's default right
No, it's moving, so it would not be, oh, it is a default in SAM, yes. So if you didn't have the schema equals where it would give you a GSI of TP : colon. All right. So SAM web get file access also has a location thing, okay? So here I gave there's 3 copies of that file. We know there were 3 copies of this file. We did this earlier. It only gave me 1. So your exercise is SAM web get file access URL minus location. And so to see the NStore Orcaster or CNUS one to make sure you get the one you want. So SAM web get file access URL file name minus location equals either NStore, Orcaster, or CNUS. I'm going fast, but Mike and I were both supposed to be done within the first hour of the tutorial. So I'm already 5 minutes over. Let's see. Every time you hear my phone go beep, that's somebody in Dune Slack asking a question on the channel. All right.
That was me,
so,
actually. You can ignore it.
Oh. All right. So then the second part of the thing is get metadata to get SAM metadata for this file. If I had a shell here, I would actually type this because it's interesting, but it shows you all the various metadata that is kept for a file. Minus JSON is interesting because you need JSON if you're ever going to update or declare stuff to SAM. It takes a JSON format to import it originally. Anybody know what a JSON format is? JSON? Anybody know how to write one wrong? You must have a comma on every line except the last one. If you have a comma on the last one, then send on you. All right, this exercise 2 here is to use SAM web describe definition command to see the dimensions of a data set. So we mentioned, I showed earlier SAM web list files, but we have what are called, they're loosely called data sets, but they're not really data sets as people are used to thinking of them. What PDSP prod 4, MC1, whatever, this is a fairly common data set that we use a lot. And the SAM query, that data set will dynamically change to always return all the files that match the parameters of that query, basically. SAM web list definition files would show all the files that match that. And SAM web takes snapshot. I'm not going to actually wait for you to get all these queries done. There's going to be more important stuff coming up. Tom is going to actually show you how to run a program here. You need to get to that, and it's going to take a while. Okay, so another key thing here, this is sort of this part of the thing is sort of a grab bag of different stuff. So it's saying, what is UPS and why do we need it? Now, if you did the mission thing, you have this source VMFS setup DUNE.sh in your setup thing. You see, we've already done this. So it now stands for is it Unix product setup or universal product setup? At one point,
Unix.
UPS actually predates Unix. It had a version on the IBM AMDOL. It had a version on the VAX. But
I always heard it Unix, but
yeah, I think it is.
Learn
It
something
does
new
stand for
every day.
Unix now. But so this has been with us. Some version of this has been with us since the very early 90s. It's supposed to be replaced by SPAC eventually, but not yet. And so what that source is doing is it's setting up a bunch of environment variables pointing you to where are the directories where all the products are hiding. Basically, that's what that thing. And the second one, you set up some software name, and then optionally a version, and then optionally a qualifier. So if you did your thing, DUNE SW version was set to something 9.0 0965 or so forth, up, down, if you followed your statement. And the Q is by which compiler and it was compiled, and then I believe we have professional and then debug, so you can have it built debug or not. Yeah, here we go. Yeah, I have it. You got E20, cool. So this E20 is the version of GCC that it was built with. With the debug built turns off optimization, right? Okay. Show all versions of software that are currently available by using UPS list minus AK plus DUNE SW. And then there are many versions available. Last time I did this, there were a couple hundred. I don't know if there's more than that now. And you pick that and substitute that for DUNE SW instead of DUNE SW for that. Now, a little bit on the Unix. If you look at your path, if you just echo $path in your Unix thing, you'll see once you've set up that thing, you'll see a huge amount of directories in your path. And once back comes along, there'll be even more. And if you say which lar, then you'll tell where is it going to find the, where is it going to get lar from if you did it. And so other things that you have for art, besides the regular executable path or CET plugin path, LD library path is there for the system objects, the .so files, fickle file paths. If you're dealing with art, somebody has their speaker on. Art works with fickle files that configure, tell art what to do, and therefore our soft also. And the FW search package, I don't know what that one is. Tom wrote this section, I'm covering it for him. So basic commands of UPS list, and you need the minus AK plus to show them all. UPS active shows what's been set up. UPS depend, that will show the whole dependency tree for DUNE SW, and I shudder to think how dependent that is. There are, what, at least 100 dependencies? Now, would somebody do that? Show me. Okay, well, any questions on either data management or UPS up till now? The next part is MRB, and Tom needs to, Tom, are you there? Tom? Tom, you out there?
Yes, I'm out here, but I have to unmute.
Yeah, I'll drive it, but you need to talk about MRB because I'm not going to pretend I understand MRB.
Somehow my mouse wasn't working to get to the unmute
Sorry, we're
button.
going so fast. I mean, raise your hand if you've got any questions. We're
Oh,
trying to
that's
catch up. We don't want to just lose everybody.
Yeah. Okay. So we we used to use good old-fashioned make, but there's an issue with the fact that we switched over to using Git from CVS and earlier version control systems. So when you clone a Git repository, you get the code from just that repository, but there are a whole bunch of repositories out there. And if we were to compile all of the code in our software stack, it would take forever. So it's set up so that you can use pre-compiled versions of most of the stack and just edit and compile a piece of it that you're working on. So that's what MRB lets you do, is it lets you compile and build and integrate just one piece into it or several pieces, when in fact there may be hundreds of things in the stack.
Okay.
I'll show you examples of how to use it.
Tell me when you want to scroll down, if at all.
Yeah, go ahead and scroll. That's in the
Right.
next section. I give introductions to all this. And you asked about FW search path. That's for auxiliary files like geometry, GDML files are
Okay.
looked up in FW search path.
Okay, now we know. Okay. Anything else on that, Tom? Anything else on MRB right now?
No,
more
I'll
come.
cover MRB.
This thing will be covered in Friday morning session, but really it will be later in this session, presumably.
Didn't
Okay, then
have to-
finally, CVMFS, which I think I can cover. So you notice we've been sourcing things out of CVMFS, so that's a quirky little file system. It actually was developed at CERN to actually send out based file systems for virtual machines. Now, CERN hasn't ended up doing anywhere near as many virtual machines as they thought they would, but the file system has spread well beyond virtual machines. And so it's basically a file system that's spread by HTTP. And it runs the auto mount, so you only see the parts of it that you actually change. It only loads what it needs to load as the time you get it. So if you just do LS on a machine or an idle machine, you won't see anything in CVMFS at all. And as you change into DUNE you'll see that part. And then if you keep on going down the directories, it will load it just as it needs it. So it's sort of a just-in-time thing, because frankly, DUNE software stack, how big is it now? What, 300? A lot of terabytes by now, right? The whole thing, I haven't added it up in a long time.
Yeah, full
But-
distribution is maybe 60 gigabytes, but we have
60
a lot
gigabytes,
of
okay.
versions- A lot of versions.
all the
of it.
versions, yeah, but
Gigabytes for
But
the
any
whole
one
thing.
version is nowhere near that big, so if you just load the one version you need at the local host, it's a lot faster. And also you can cache it, so you make use of squid proxies at all the various sites, and then if I'm running 500 jobs at a remote site, then I only have to download all those files there once. And the base thing that sends doing OpenScienceGrid.org out is at Fermilab. There's certain software publishers can publish to update it as we need to. But it's read only. You can't modify anything in that area. If you try to just touch if you try to edit any files in that area, you won't be able to do it. It's read only. So if you do CV, in the exercise, you do CD, CVMFS, and do LS at top level, you should see that. Those four. Doing OpenScienceGrid.org, Larsoft OpenScienceGrid.org, Fermilab OpenScienceGrid.org. Doing OSGStorage.org is actually what's called stash cache. And that's used not for doing code, but for doing things like flux files is probably the biggest thing we use it for right now. So if you have a lot of files that are going to need you to a lot of jobs that are of intermediate size, say sweet spot is like between 10 to 100 megabytes or so. If you have a lot of them, then stash cache is your way to go to do that. And that's what's in DUNE OSGStorage.org.
Yeah, just a question for people, the CERN people, can you see the CVMFS? So can you do a LS on that CVMFS and see if you can see it for one of our CVMFS directories? Because you should be able to have access to
Right.
our code.
Yeah.
What?
Yes.
Okay,
it's
good.
there. The other thing that you'll hit eventually, and Ken will cover it, is that there are four called, what is it, FIFE user 1, 2, 3, and 4.OpenScienceGrid.org. Those are rapid code distribution services that we send user tarballs out in CVMFS as well. All right. And then try to go to DUNE OSG storage. Okay, so yeah. If you look at this particular directory that I've got here, DUNE OSG storage, PNFS, FNL.gov, Photon library data, you'll see the Photon libraries that are used in Larsoft for simulating photon showers in liquid argon. So we don't, if I understand it right, and somebody can correct me, we don't actually shower every photon out in JM. We have a bunch of libraries and we put in different ones as time happens. All right, there's user. So we went fast on that. Key points to remember: SAM and Rusio are data handling systems used by DUNE to retrieve data. Staging is a necessary step to make sure files are on disk, decache, and tape. Especially if you're planning to read a whole bunch of stuff that hasn't been read for a while. Like the far detector vertical drift Monte Carlo, which was generated about 6 or 8 months ago, and nobody's been looking at much. Recently, now I have to move that across the world. I have to, for something that big, I should give my guys in the tape thing a heads up saying, hey, this is coming. We had a ugly situation in Fermilab where a couple other spokesmen of not DUNE, but other experiments who will remain nameless were grabbing each other in the hallway and saying, why are you guys screwing up the tape robot? No, why are you guys screwing up the tape robot? And said, it wasn't that pretty. All right, multi-repository build and then CVMFS. So we're done with that session. I went fast, but we've got a lot more to get through. Next, who's up next for the next, any questions on this whole session point?
Anybody actually, have we actually had some